Okay, we're going to start with the one that says Old Faithful worksheet. What we talked about last time was taking data that was qualitative or categorical data and summarizing it into a frequency distribution and then making graphs from it. And those graphs that we made were pie charts, bar charts, Pareto charts. And from there now we're going to go into how do you make graphs that are for quantitative data. Okay? Quantitative data is, if you remember, it's either interval or ratio, meaning it actually is counts or measurements of some kind. This is actually a sample of height measurements in feet for the eruptions of the Old Faithful geyser in Yellowstone National Park. Now, since these are height measurements in feet, what kind of data are these? Quantitative, and what level is that quantitative data? Ratio. Very good. So what we're going to do to summarize this data, because if you just look at this data, you're sitting there saying, okay, I can't make any sense of all these numbers. Let's see if we can organize it in some way that we can make sense of it. The first thing I'm going to do isn't on this sheet. I want you to get your calculator. We're going to learn a little something that is actually going to help you in the next chapter. We're going to get a little bit ahead of the game. So take your calculator out. It over here before it's going to let me have my handles. Okay, so I think everybody can probably see the calculator there. What we're going to do is we're going to go into the stat menu, which some of you have already gotten to in the other part of the class and started learning how to do some of these things. We're going to go to the stat menu and we're going to press enter to edit, and there's stuff in those lists. So what I want to do is I want to delete that stuff. Okay? So make sure that you have hit stat, enter to go into your spreadsheet, because this is just like Excel. You know, in Excel we were able to put things into a table. Well, this is the same thing. Now what we want to do though is we're only going to use one column, and we're going to go through and enter the values that are on this sheet into that column. Okay? Now, I don't care if you go across the page, you go down the page, and then to the next one and the next one, but enter the data. So let's everybody take a couple of minutes to enter the data. Delete a line. Let me see
Yeah,
what
if you
you,
deleted stuff, I can tell how to do it. Push clear and push delete. I got mine with the
go to the top and it's easier. Okay, where did you put too many in?
No, there's like one on the
Okay,
way.
you just hit delete. Not clear, delete. Okay. Now, actually, if there was data in there and it was shorter than the list we're putting in, we could have just typed over the top of it.
Okay.
Now, be careful that you enter the numbers correctly. We're going to go back and we're going to make sure, we're going to scroll through and make sure we didn't misenter anything. So I've entered mine going down each column, so I'm going to scroll back up and just double check.
It's only like we put in 6 lines.
No, you don't want to, that's not what you need to do. You need to go all in one column. Okay, mine are all in. When you get all of your data in, you're finished editing it, look up so that I know that you're finished. And be sure you're putting those numbers all in one single column. everybody finished? Okay. No? Yeah, you had to start over, so it's going to take a little longer. That's okay. Okay. Now, I'm going to give you an overview of what we're going to want to do with this data. What we're going to want to do is we want to find the largest one and the smallest one. Now, it tells us, if you read at the top of the page, this Old Faithful erupts every 35 to 120 minutes for a minute and a half to 5 minutes. Its maximum height ranges from 90 to 184 feet. Now, none of our data contains the shortest one or the tallest one. They know that since it's been erupting, that's the shortest and the tallest ever recorded. But we've just taken a sample here, and we didn't get either the shortest or the tallest eruption. So what we have here is a random sample of height measurements in feet. And what we have is, let's see, 1, 2, 3, 4, 5, 10, 15, 20, 25, 30, 35, 40 eruptions. Okay? I need to know the shortest one, and I need to know the tallest one. Now, you can comb through that table and find those out. But if we had a larger data set, you don't want to comb through the table to find it, because it's a little troublesome to do that. So what we're going to do is we're going to hit stat on the calculator again. And we could sort it, but I want to know a little bit more than just the largest and smallest. I want to actually give you a taste of what we're going to do in the next chapter. So what we're going to do is we're going to right arrow over to Calc, to the Calculate menu, and we're going to choose the first option, which is one variable statistics. So it's going to give us some summary information about this data. And if you don't put a list in at all, it's going to default to list 1. So as long as you're using just list 1, you're fine. Or you can enter second and L1 and hit enter again. And it gives you information at the top that we're going to talk about in a minute. But what I want to do is, you see that little arrow there next to 40, which means there's 40 pieces of data. Press your down arrow key. Now, these 5 numbers are important numbers. We're only going to talk about 3 of those numbers today. We will talk about all the rest of them a little bit later. But that tells us that the minimum data value is 95. And it tells us that the maximum data is 150. Okay? Now, the other ones I want to draw your attention to are the one that says MED. MED is median. How many people know what a median is? It's the middle value, but what do you have to do before you can find the middle value in that data set? Yeah, you have to range from smallest to largest or largest to smallest, one or the other, in order to find the middle number. But the calculator found it for us without us rearranging it. So the middle value of that data is 130. The other number I want you to notice is the one at the top. It says X bar. That is the symbol that we'll learn about in the next chapter for the sample mean. The way that your calculator arrived at that was it added up all 40 of these numbers and divided by 40. And it's actually even telling you here that if you add up all 40 of the numbers, it's 5088. So 5088 divided by 40 is what we call the mean. So one of the things I want you to do at the top of this sheet, just make a couple of notes here, is that the mean, and we're just going to use the words right now, but but the symbol is X bar. The mean was 127.2, and the median was 130, I think.
Yeah.
And then there's one more measure that we're going to learn about. These are called measures of central tendency, and that's called the mode. Okay? Now, it would be nice if the calculator would tell you what the mode was. But unfortunately, it's not on any of the lists that I have found so far. And I keep thinking someday they're going to make it learn how to tell you the mode. So these are all the statistics values your calculator can calculate. And this last one is just points. So it'll find the median but not the mode. So in order to find the mode, does anybody know what the mode is? Not of this data set, but you know, how do you find a mode? It's the one that shows up the most, the one that appears the most. In order to do that, rather than have to, once again, comb through all this data, which is, you know, a lot of tedious work, it would be nice if we could get the calculator to help us. And somebody mentioned earlier that we could sort the data to find the max and the min. And we indeed could. But if we sort the data, it'll put it largest to smallest, and then we can figure out which one is the mode. So we're going to sort ascending. You just hit stat and choose number 2. And then tell it which list you want it to sort, because it won't automatically choose one. And when you click, after you've got sort A and then put L1 in the parentheses and hit enter, it just says it's done. It doesn't show you anything except to say that it's done. But if you go back to stat once you've done that and you look at your data again, now it's sorted from smallest to largest. And I see that I have 295s and 310s, 215s. There's 1, 2, 3, 4, 5, 6, 7, 8. There was 8 120s. There's a good candidate right there, was the 120, because there was 8 of those. So I'm just going to make a note of that. And then I see 1, 2, 3, 4 125s. 1, 2, 3, 4, 5, 6, 7, 8. 8 130s. And y'all count along with me, make sure that I don't miscount. And then 1, 2, 3, 4 136s, 1 138, and 2 140s. Nice. Wait, more 140s than that. Let's see. 1, 2, 3, 4. 1, 2 148s and 2 150s. So this data set actually has 2 modes. It's what we call a bimodal data set. It has 2 modes. The modes are 120 and 130. So we'll just make a note of that. Those will help you kind of get set in your mind when we talk about what the histogram looks like. We can look at where those fall on the histogram and where that falls in your frequency distribution. So now what we really want to do is we want to actually build a frequency distribution. What we're going to do to build that frequency distribution, now that we have all that data sorted out, We want to make a frequency distribution that consists of 6 classes. In order to do that, what we're going to do is we have to figure out where those classes begin and end so that all the data will fit in every single one of those. And if you're tempted to say, well, we could just start one at 90, and one at 100, and one at 110, and one at 120, and one at 130, well, we've already run out of classes and we still have data. So you can't just arbitrarily set it to count every 10 if we want 6 classes. So what we're going to do, since we want 6 classes, is we're going to take the class width by taking something called the range, which is the maximum minus the minimum, and we know that the maximum was 150 and the minimum was 95. So 150 minus 95 is 45. And we're going to divide by 6 because that's how many classes we want, is 6 classes. Yes, thank you. You would think a math teacher could do arithmetic. Zach, you got a bonus point. I put it on the class roll. Okay, so 55 divided by 6. So I'm going to use my calculator. I'm going to clear all that stuff off. 55 divided by 6. And that comes out to be 9.1666666. Okay? Now, because of what will happen if you don't, even though you normally would round that to what? What does 9.16 usually round to if I round to a whole number? 9. But you're going to have to round up to 10. And the reason is, if you only round up to 9, what we're going to do is our smallest data value is 95, and I'm going to show you what happens. If we start with 95 and we add 9, the second class begins at 104, the next one begins at 113, the next one begins at 122, 131, and 140. So that means that last class is only going to go to 149. What's our maximum data value? 150. So it's not going to fit if we leave it at 9. So we always, always, always round up. That's very important. You always round up. Even if 9 had come out, even if that had come out to be exactly 9. If the range had been 54 divided by 6 and it came out and it said 9, we still have to round up to 10. It's not just because it's a decimal. You always round the class width up to the next value, and what you look at to decide how, do you want to round to a whole number? Do you want to round to the nearest tenth? How do you want to round? Go back and look at your data. Your data in this case is whole numbers. So you're going to round up to the nearest whole number. When we get to the other worksheet, I'm just going to mention this right now. We're going to do the same thing. But there is some data, one of the sets of data that we collected for our class, our data set, was how much change did you have? How many decimal places is that data going to have? 2. So we would round up to the nearest 2 decimal number if we were trying to find class width for that. Okay? You keep the same number of decimal values as what your data has, but you always round up. So now we're going to start doing what we call class limits. Your lower class limit, which we're going to just abbreviate LCL, the first one starts with the minimum data value. And that was 95. So 95 plus 10 is 105. And 105 plus 10 is 115. And 115 plus 10 is 125. And 125 plus 10 is 135. And 135 plus 10 is 145. Now, if this class begins at 95 and the next one begins at 105, what's the largest number that's going to be in the previous class? 104. Now, I could do that with all these numbers, except when I come to 145, I don't have a next number, so I have to do a little arithmetic. But I added 10 every time to get the next number. So I can do the same thing with 104. 104 plus 10 is 114. Plus 10 is 124. Plus 10 is 134. Plus 10 is 144. Plus 10 is 154. And my 150s are going to fall in that last class. Okay? So the next thing we're going to do is the same thing we did with the concept of frequency. When we were looking for frequency, how did we determine the frequency for categorical data? You just count them, right? Okay. How many numbers do we have from 95 to 104? And again, it's easier to use your calculator, so go back and look at your data list in your calculator, and it opportunely decided to shut down on me. So from 95 to 104, I only have 2 numbers, and that's 95 twice. So there's 2 of those. For the 105 to 114, I see 1, 2, 3, and the next one's 115, so that's too big, so there's 3 that go in that one. And then for 115 through 124, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 125 is too big, so there's 10. So then starting at 125 and going to 134, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 136 is too big. And then beginning with 136 and going up to 144, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, so in my last class, 145 to 154, I've got 1, 2, 3, 4. Now, if I counted correctly, what should this add up to? Okay, let's see if it does. Let's make sure we didn't mess up. I always double check this, because if you don't double check, then you're going to find out that you messed up.
There's 12 and 1.5.
Okay. So y'all already caught it. But if you're sitting at home at night, or I was sitting at home at night, I don't have y'all don't have my back at night when I'm not here. Okay? So what I would always do at night when I get home is I would say 2 plus 3 plus 10 plus 11 plus 9 plus 4. Oh, that's only 39. I miscounted somewhere. And then I'd go back and see where I miscounted. So yeah, it was the 11. It was the 11. It was supposed to be 12. So that's supposed to be 40. Because we know we had 40 numbers. Okay? Now we're going to talk about midpoints. The midpoint is the middle value of each class. Just like median is the one that's in the middle. The midpoint of the class, and these, by the way, were called the upper class limits. You find the midpoint of a class by finding the middle value. Now, I could do it this way. I've got 95, 96, 97, 98, 99, 100, 101, 102, 103, 104. Oops, I got 2 numbers in the middle because I have 10 numbers. Okay? So the middle value would be 99.5, I think. Okay? But the best way and the easiest way is just to remember a little formula. Take your lower class limit plus your upper class limit and divide by 2, and you'll always get the right midpoint. So 95 plus 104, enter, divided by 2, enter, 99.5. Okay? Now I could do that for all of these, 105 plus 114 divided by 2, and get the next one. But again, how did I get from here to here? Add 10, add 10, add 10, add 10, add 10. Same thing here, 10, 10, 10, 10, 10, 10. That's why getting this part of it is correct is so important, because you don't need to do anything arithmetic-wise to find the rest of your midpoints. Add 10. And your next one is 109.5. Add 10 again. 119.5. Add 10 again. 129.5. Add 10 again. 139.5. Add 10 again. 149.5. Right now, you're not going to see a lot of benefit to having done that. But when we do something called calculating statistics from a frequency distribution rather than the raw data, these will be very useful. Because instead of having to enter all 40 of those numbers, what we can do is we can assume that all the numbers that were in there were 99.5, and we'll make the assumption that all the numbers in here were 109.5, and we'll come up with a really reasonable estimate of the mean of the data, rather than have to add up all 40 numbers. So it makes for a nice shortcut later. Relative frequency. Doesn't have anything to do with your relatives. Relative means when you look at it in the context of something else. If you've got a bag full of candy bars and 10 of them are your favorite candy bars and the other 15 are not, the relative frequency of your favorite candy bar in that bag is going to be 10 out of 25. Okay? It's whatever you're looking at compared to the whole. In this case, 2 out of these 40 numbers fell in the first class. That's relative frequency. So 2 out of 40, which is 2 divided by 40. You can reduce the fraction if you want to. I don't care if you reduce the fraction. I'm not your arithmetic teacher. 2 out of 40, what I would more likely do is say 2 divided by 40 and get a decimal. Or maybe even change it to a percent. All 3 of those are correct. Just watch your instructions for which way they want you to show the relative frequency. And then 3 out of 40 are in the second class, and that's going to be 0.75. And that is 7.5%. Don't call that 8%. And then we have 10 out of 40. And I think I can do that one in my head. That's 0.25, which is 25%. And then we have 12 out of 40. So that's 30%. And then we have 9 out of 40. And that's 0.225. Or 22.5%. And then 4 out of 40 is 0.1 or 10%. So relative frequency can be a fraction, it can be a decimal, it can be a percent. If I add up all of these fractions and I did it right, this should come up to be 40 out of 40. And I know that it is 40 out of 40 because I already added these up once to make sure I got 40. And 40 out of 40 is 1, which is the same as 100%. So when you add those relative frequencies up, you should have all of your data, which is 100%. Yes, ma'am?
So if we do, like a fraction, would we need to simplify? No?
My math lab may ask you to, but I don't care. I'm probably not even going to ask you for the fraction as a frequency. I'm more likely to ask you for the decimal values and then tell you how I want it rounded. Okay? So now we have one more thing. We have something called cumulative frequency. And the word cumulative comes from the word accumulate. What do you do when you accumulate things? Yeah, you add them to you. You add them together, you bring them all together and make a total out of it. Okay? So what that means is the cumulative frequency at the first class is the frequency of the first class, because at that point, that's all you got. But by the time I get to the second class, I've got 2 plus 3, which is 5. For my cumulative frequency. And then when I move to the third class, I'm adding 10 more. So at this point, I have 15 of the 40 data values. And by the time I move to this class, I have 12 more. So I have 27 of the 40 data values. And then when I move to this class, I have 9 more. So I have 36 of the data values. And what should this last one always be? The total data values, because at this point I've got them all. So when I add 4 to 36, I should have all of them. And N, like I said before, I think, is called the sample size. So the cumulative frequency for your highest class should be the total of all the data values, because you should have accumulated all of them in at that point. Now, does that make sense to everybody? Anybody have questions? Okay. What we're going to do now
I'm with the Learning Center.
okay, they already saw,
Same class?
yeah,
Okay. Sorry about that.
that's okay. Thank you.
Thank you.
They're trying to make sure everybody knows they're there. And that's a good thing. Okay, at this point, what I want you to do, I'm going to show you first how to do this on your calculator, and then we're going to go to Excel. Okay? You can make a histogram on your calculator. In order to make a histogram on your calculator, the first thing that we're going to do is we have to, first of all, go to second y equals, which is your statistics. It calls graphs plots. Okay? So we're going to go to the statistics plots, and we're going to choose plot number 1. I never use anything else but plot 1, because you're never going to want to look at 2 of them on one graph window. At least I don't. I'd rather go do it in Excel if I'm going to do that. Make sure that it's on. It's sitting there blinking on. So make sure that while it's sitting there blinking on, that you hit enter, so that when you press your down arrow key, the on stays lit up. Second, y equals. And then while your cursor's sitting there on, because it'll pop up on, hit enter. Now, some of you have newer calculators that may not look just like this. So if yours is different, you need me to come look with you. Press enter to turn it to choose that. Now press enter again to make it save. How do you do down here? Sit there for a second.
What did I do with that?
Enter while it's on.
That's
Now you do it.
minimize that.
And see how it stays lit up.
It's over
Turns it
there.
on, the light switch turns it on. If you would have pressed it again, it'll turn it back off. Okay? If your neighbor's having a hard time and you know how to help them, go ahead and help each other. It's not going to do that. That calculator wouldn't work in this class. And you can pull it up on the computer. But you won't be able to on test day, so you're going to have to get an TI 83 or 84. Second, y equals. Okay. And then press enter. And then enter again to turn it on. And then down arrow. And you're where I am. Okay? Okay, at this point, a histogram looks like a bar chart. There's one really important difference between a histogram and a bar chart, but a histogram looks like a bar chart. Which one of those pictures looks like a bar chart? The third one. Go put your cursor on the one that looks like a bar chart. Just use your arrow keys. When you get to the one that looks like a bar chart, press your enter key. Okay? And when you hit your down arrow key after that, it should move down to the list. So you should have on be lit up. You should have the histogram picture lit up. And you should have X list as L1 because that's where we put the numbers in when we started. Okay? So as long as your screen looks like this one, you're good to go. We're going to go to the next step together. Okay. You don't have your data in, do you? Did you just now turn it on? Okay. Look on with Mark for a few minutes, and then if you need help, I'll help you get it done later. Okay, anybody that does not have their screen looking like mine? Okay. Now, in order, there is a nice shortcut feature that you'll learn about later called Zoom Stat, but we're not going to use it today. We want a very specific histogram. We want a histogram of these values. So from here, we're going to go to the window button. Okay? We're going to go to the window button. Your minimum X value is going to be 95, the lower limit of the first class. Your maximum X value is not going to be 150 because we're looking at the classes. So the top of the top class is 154, but because of the way the calculator makes things, if you put in 154, it's going to look like it left off part of the last bar. So what we're going to do is we're going to go one more than the upper class limit, which is 155. So the last upper class limit is 154. We're going to add 1 to it so that it'll have room to draw a line and show you the last bar. Your X scale is your class width, which was 10. Your Y minimum value is going to be the bottom of all the counts, which would be 0 normally, because you're not going to have negative values. And then your highest frequency is 12, so we want to go one more than the tallest. We're going to go to 13. And we want it to count by ones. Just like we counted by ones, we want it to count by ones. And at this point, you can hit your graph. Well, we're going to do one other thing because I don't know where my calculator's been. At that point, hit your Y equals, not the second Y equals, just Y equals. Make sure there's no graphs on there. Make sure there's no equations in your Y equals menu. Because if there are, it's going to show up on your histogram and you're not going to know where it came from. So make sure that screen only has plot 1 on it, and then you can hit graph. Okay? So that's what the histogram looks like. Now, what do you notice that's different about the histogram that's different from the bar charts we made or the Pareto charts we made Monday? What's the one big, huge jumps right out at you difference? Okay, that's one thing. Okay, it didn't do that because that was a Pareto chart. When we made the bar charts, did the bars touch? No. But now the bars touch. Is it okay for these bars to touch? Yeah, because what comes after 104? 105 immediately, okay? In fact, after you pass 104.5, not that our data had decimals in it, but anything 104.5 or higher, we would have counted as 105, okay?
I think it'd be 105.
Okay, let me come see. Because that's your frequencies. I mean, you're one of those, you don't want the frequencies because we don't have anything. There's nothing in this section.
Yeah. So, why wouldn't we just cancel it out?
I think actually you can. It's right. But I'm still gonna find it. It should have defaulted to one, I don't know why it didn't. From now on, it should default to one at a time, what you put in there should change. Somebody else will put that.
Yeah, cause I mean, when I used to.
Right. Okay. Okay, we good to go? Your clock's still off. See? So what you do when you first get on, or get in, or make it on. When you move down, that should stay with that. Okay, and then you just get gray, you follow it. Okay? Then it goes to the arrow, let's see what. Puzzled as you are. All kinds of goodies here. All but where it goes, or someone is going to break. Yeah, somebody. They got all the blocks on, Lord knows why they put them all on, but. with your graph up here? You said there was no numbers on it, right?
That's what I said.
There's no numbers on it. What good is this? There's no numbers on it. You have to find the numbers. Hit your trace button. Your trace button puts a little cursor at the middle of the first bar, and it says for that bar the minimum value is 95 and the maximum value is less than 105, which is 104. And the number of data values that fit in that bar was 2. If you move to the right, it says in the second bar, the numbers in that bar are 105 to less than 115, and there were 3 of them. If you move to the right again, it's 115 to less than 125, and there's 10. Tallest bar is 125 to 134, and there's 12 of them. The next bar is 135 to 140, less than 145, and there's 9 of them. The last bar is 145 to 155, less than 155 actually, and there's 4 of them. Now here's the secret. You could have actually done what we just did as long as you created your class width correctly, as long as you got your class width calculation, range divided by 6 and round up. As long as you know your class width, all you have to do is go in here and pick out your minimum data value, which was 95, and then add 6 times 10 to that. So 95 plus 60 is 155. And you could actually do that arithmetic right here. Your class width is 10, and you have 6 classes. Sorry, I messed up. It's supposed to be 95 for that first class width, or the first value, plus 6 times 10 for the class width. 6 bars, 10 units wide. There's your upper. Your class width is 10. The only thing you won't know is Y max. And the way that I usually figure Y max is I look at how many pieces of data I've got and I divide by about 3. And then if I need to, I can move it up, or if it's like, all the graphs down here and my window's way up here, then I can change it down. So you could have actually created this entire table as long as you calculated the class width correctly. Your calculator would have done that for you when you were making your histogram. Okay? Now you don't have to do it that way, but it's a good way to check to make sure that you've done your class widths right. So that's basically what we need to know for that part. And now we want to switch over to Excel. So let's open up Excel. And when you get to Excel, you're going to have to do some data entry again, unless you open the Word document. So if you open the Word document on the computer, which you can get from Shobi, go into Shobi and open the Word document, which is why I gave you the Word document as well, even though that might not be the one you're using. If you click on that Word document, it will select the whole entire table. And then you can copy that table and if you want that data set in here, you could actually paste it in here so that you know what you're looking at. Now granted, normally I would want all those numbers in one column. But since we've already done all of the sorting and all of everything else with it, then I don't care if it's in one column or not. So if you want your data table in Excel, you can copy and paste it from the Word document. That's just something for you to know that you might find useful. What we really want to do here, whether you got that or not, is we want to type those class limits and the frequencies into a table in Excel. So what I'm going to do here in my Excel sheet is I'm going to just pick a place, I don't care where you choose, pick a place in the sheet somewhere, and type the word class limits. And then in the cell next to it, right next to it, don't leave any spaces. Make sure that you widen that column so that it'll actually hold both words, class limits. And in the next one, we're going to type frequency. And we're going to spread that out too so that we can see the whole word. And then in the boxes below class limits, I want you to type your class limits for each of the 6 classes. 95-104, 105-114, 115-124, 125-134, 135-144, and 145-154. And then type in your frequencies. Type your frequency distribution into Excel. If you don't want to put the data table in there, you don't have to. That's a lot of entry work if you're going to enter it by hand. Give everybody a minute to get your table built. That's okay, it doesn't matter. It's on. No, it doesn't matter. It doesn't matter if it puts your numbers centered in the space or if it left justifies them. That doesn't make any difference. Since the data table above it was centered, it may try to center those too. See that? Yeah, and you don't want this in between, because if you do have that in between, it won't work right. So we're going to delete and make sure that's correct. Like it had a look, think of it as an arm shoving the thing open. Okay? Do you want your data in there for any reason? You don't have to. You don't have to. No. Okay, then just type in your table. all your data highlighted, you don't even need it. You don't even need this model. We're just gonna use that one, okay? But I'm gonna show you how to do it. And the histogram may work for you, I haven't, I want to some of them short like that one. Yeah, it's not gonna work. That's all what I'm gonna show you. Okay, has everybody got their table in? Anybody who does not have their table in? Because we have to all be together to do the next step. The way you make it automatically space out. Like the word frequency right there. And then once you type that word in, you know it's too long, then you go right here. You just, once down, you just click on it. Double click. It'll automatically space it out. Okay, if you've got your table, you're gonna need to pay careful attention to the next step. This is not as straightforward as what we did yesterday. Highlight your frequency numbers, not the title, not the word, just the numbers. Highlight your frequency numbers. Then click your insert button. And yes, I know it's tempting because there is something right there in the middle that says, that looks like a histogram, okay? Okay, but the problem is that's not the right histogram. Okay, that's the problem. So here's how we're going to have to do it. We're going to go make a bar chart which looks a little like the histogram that we want. Okay, but we're going to have to fix it up. For one thing, that bar doesn't represent 1, that doesn't represent 2, that doesn't represent 3. Let me see if I can get my fonts bigger so that you can see them better when I'm talking about them. Actually, I don't want them quite that big. Okay, first of all, let's figure a name for the chart. What do you want to call the chart? What's the data? What's the data itself? What was the sample of? Geyser heights. Old Faithful heights. That tells anybody that's going to look at our chart what they're looking at. Second thing we need to fix is we need to have axis labels. So go to Design, and all the way over to the very left-hand part of the ribbon, you should see the words Add Chart Element. You want to do axis titles. Slide down and look at the second choice. There are two axes. There is a horizontal axis and there's a vertical axis. Let's do the vertical axis first. Now Now, all it did was it put in a box to put that title in. What you do is go up here and click at the top and type in what you think that axis should be, and that axis is frequency. Frequencies, because that's the counts. You can use the words count, the word counts also. And again, I'll make mine a little bit bigger.
Wasn't the axis or the X tiles? Which one?
This is the vertical.
The vertical?
We did the vertical one. Okay, now same selection again, add chart element, go to axis titles. This time we want the horizontal axis. And what those bars represent is heights in what? Feet? So basically, you just want this to be descriptive. So far we've got it labeled appropriately. If somebody was looking at it, they would be able to make sense of what it represents until they come to these numbers. They're going to look and say, what? A geyser that erupts 4 feet tall? You sure that's a geyser? Maybe somebody just broke a water line? And that's because what we want on there is this. So what we're going to have to do is we're going to select that again. Select your chart, make sure you're still selected. And go, this time not design, go to format. Oh, wait, no, I'm sorry, my bad. Go back to design. Go back to design. And over here, it says select data. You've seen this before. We looked at this last time. Remember? Right now, this is fine. We want that to be exactly what it is because that's the heights of the bars. But what we want over here is not 1, 2, 3, 4, 5. What we want is to click the edit button and then go click and drag on your class limits to select all your class limits. And notice that when you do that, it immediately puts the class limits underneath all the bars. Okay? Now I'm going to back out for the benefit of somebody that needs to see it again. I'm going to go from the beginning. So I make sure my chart's selected. I go to design. I go to select data. Under horizontal axis labels, I click edit. And then I click and drag. And then tell it OK. So now the chart is appropriately labeled. Okay? Only one thing left. Bar charts, bars do not touch because they are categorical data. Histogram bars touch. Click any one of the bars. They should all line up. You should select all of them. So once you've selected the bars, right click on any of them. Right click on any of them. And this is what should come up. Go down to Format Data Series. Raise your hand until you get where I am. If you're not there, raise your hand. Not if you are there. If you're not there, raise your hand. No, I said it right the first time. You heard it wrong. Okay, you're not there yet. Choose one of those. Okay, you're good. Stay right there. Right. Down the bars. That brings it back. Nice and still. Okay. Try to make sure everybody looks like they've got where they're supposed to be. Okay? This part's easy. What does that word say right there? Okay, do we want the bars to overlap? No. So we're going to leave that alone. What does it say underneath that? What's a gap? Space. There's a gap from here to here, right? I want to close that gap. It's easy to close the gap. Put a 0 in there. And then hit enter. Okay? Now, while we're still here, I'm going to have you do one other thing so that we don't have to go back through this process again. After you close the gap, by typing a 0 in for gap width, I want you to go to the little paint can, and we want a border. You want a solid line border, and you want it to be any color but the same color as the bars. And right now, it's the same color as the bars. So pick a different color. I like black because it shows up good, but you know. So now when you click off your histogram, you have a complete, very informative histogram. Line. You're not selected. Select your bars again. There you go. Okay, now. And then solid line. Border. There you go. Steps out of it. Okay? Now you can close that because you're done with it. There's your histogram, and it's, if you click over here, you'll see that everything's labeled the way it ought to be. Okay? You have made your first histogram. Now, remember the numbers I told you that I wanted you to calculate, partly to help us with getting ahead for chapter 3? Let's talk about this a little bit. The mean was 127.2. Which bar is that in? That one. Because it's 125 to 134. So the mean, if this were actually 10 numbers, the mean is probably right about there. Right? Probably falls right about there, where I've got my cursor at the top of it. Where's the median? Same place, but over a little closer maybe to the middle of the bar, right?
Yeah.
So more like about there. What were the modes?
Most frequent. correct.
Okay. Most frequent, well, one of them was 130. Look what bar it's in. What's the next tallest bar? One to the left that has 120 in it. Okay? The reason these are called measures of central tendency is because they tend to fall toward the middle of all the data values. This data is spread out to where its middle is in the middle. Not all data values are like that. If I, for example, had all of y'all, I brought in my change jar that has pennies in it. I've got two change jars. I've got one that's got pennies. It's like not this deep, about that big around. It's a good doorstop. It really is. And if I could lug it in here and let everybody take a handful of pennies out of it, there's pennies in that jar that my grandmother started collecting those pennies before she died. So she died in the 90s. She started collecting them in the 70s. She didn't keep them, she gave all of us some of them, so I have part of her pennies. And since then, I've added my own pennies to it. So there's pennies in there from the 70s all the way up through the 90s. Now, some of her pennies were not necessarily 1970 pennies. So if I had everybody in here, we shook up that jar of pennies and let everybody get a handful, and we were trying to figure out what the range of data values are in there. Now, I put more pennies in it than she did. Because I started in 90 and I put in pennies from the 90s, and then after a while it got too heavy to carry around. So I don't, they probably ended at about 2000. But she had pennies that she had forever that were for like 1913. So if I were to get all those pennies and count how many for each year, would I have a lot for 1913? No. Because, it's 1960, she probably had maybe 2 left from 1913. Okay? What are most of the pennies going to be? 1990s. Okay? Because I was putting them in the 90s. Might have been, a lot of 1980s in there. That wouldn't have been terribly unusual. So, guess what the shape of my histogram would have been? Would it have looked like that one? Probably not. In fact, my penny histogram would probably look more like this, and I'm just going to sketch it. Imagine that these are the same width. You have to have a good imagination when you deal with my drawings. Okay, so these are separated out by decade. Is the middle value for the year of my pennies going to be in the middle of here? Yeah, it's probably going to be somewhere in the 80s. Okay? Because she only had, 1 or 2, and then, maybe 5 or 6. Mine, 1990s, actually would probably be even taller than that. That data set is called skewed left, meaning it starts out low and goes high. Okay? Starts low, goes high. That's skewed left. starts high, goes low is skewed right. If I took the ages of all the students enrolled at Northeast State in any given semester, I would have a histogram that starts out high because most of our students are 18, 19, 20, 22, 25. But last semester, in the summertime, I had a student that was 73 years old. And I have a lot of students in my evening class even now that are in their 30s and 40s because they're coming back to school. So yes, we have those students, but there's not as many of them as there are recent high school graduates or people that are still out there in the workforce and trying to figure out where you want to go with your life. Okay? So those kind of data, those kind of histograms would be starting high, going low, and we call that skewed right. But the histogram that we're looking at, that we just made, we would say is sort of symmetrical. And I'm using the word sort of because it's not exactly perfectly centered. But it does, it starts low, goes high, and then comes back down. If there was another bar or two out here that were progressively shorter, I would say it was very much symmetrical or normal, okay? But the distribution of data tells you a lot, and the best way to see the distribution of data is through a graph. So your assignment, now that we've finished our practice, is to go to the Disney Movies worksheet and complete the worksheet. You're going to practice what we've already done. And the second page of the worksheet says make a frequency histogram. Now, when you make the frequency histogram, you're going to use Excel. Since it's such a pain in the hiney to have to try to convert an Excel workbook to a PDF. Let me show you how we're going to have you submit the Excel document.
Do we need to save this one?
You probably do, so you can go back and look at it and remember how you did things, but you save it for you, not for me. You don't have to put it on Shobi or anything. I'm going to bring my histogram back up. I'm going to select the histogram. I'm going to right-click on the histogram. And I have the choice of copying or move it somewhere. What I would rather do is neither one of those. I just want the histogram selected. Now you can do that. You can copy it and paste it into a Word document. But if you select just the histogram and you go to File and you go to Save As, pick a place, My Document, Desktop, wherever you want to pick. You can save it, but the other thing that you can do is you can, while it's selected, click Print. And notice that the only thing that comes up is the histogram, not the whole workbook, just the histogram. So you want to print, no, they don't have it, so we're not going to print. We're going to go back to Save As, Desktop, and choose PDF. And I'm going to call mine Old Faithful so I can find it. And there it is. So now, since I know this is on the desktop, I can go back to Shobi and I'm actually going to go ahead and do this in the shared folder. Click a plus sign, add from the computer, go to the desktop, Choose the Old Faithful file, open it, post it. There's the graph. Just the graph, and that's really all I wanted to see was the graph. So when you do your Disney worksheets histogram, just select that histogram when you're done with it, save it as a PDF, and then upload the PDF into that file, and that, so the second sheet, you're not gonna have anything on it. Okay? You're gonna show me the one you made in Excel. Now you have the rest of the class to work on that assignment. If you don't wanna work on it right now, you've enjoyed all your, you can stand, that's fine, but it is due at 11:55 tonight. Okay? Best time to practice is right after you learn how to do it. So it's due tonight. Okay. So what you should be submitting is two things. You should be submitting the Disney worksheet filled in, the first page only, and then you're gonna submit me the histogram of your frequency distribution for the Disney worksheet.